I welcome you all for this program, sir. I would like to introduce Dr. Anbarsan. He's a doctorate in electrical engineering. Basically, he has done a lot of research work in the reactive power dispatch topic, and he has completed his PhD in 2020 only in VIT University, and before that he has completed his masters in 1997 through Anna University, and his UG was from Regional Engineering College, Bhopal. So he has been a lecturer since 1997 in VIT till date, and he is taking subjects of various electrical engineering discipline like DC machines, transformers, AC machines, like that. And he is also a member in the curriculum board decision making, like that. The subjects which are to be taught in the university are being decided by the board. In that board, he is also a member, and he has made a lot of research papers and presented in various international forums. And with this small introduction, I request Dr. Anbarsan to take over and give his lecture on the topic of energy conservation today. Thank you, sir.
Yes, sir. I thank you for Manoharan sir, the manager, BHL Ronipet, and also my colleague husband Aramugam. Both of them they given opportunity to deliver this lecture, the energy conservation for present and future. It's the good time for deliver this topic. Actually, the Energy Conservation Day, December 14th, every year we are celebrating in India. We have to create the awareness for the people how to save the energy. So for that saving energy, that cost loss, the power loss, everything, how we are going to be safe for this. So for this, we are going to create awareness. So the topic they are given for me. So I'm going to deliver this lecture topic, energy conservation and present and future. Sir, my voice audible, sir?
Yeah, actually, when you were asking for audible, that was quite.
Yes, sir.
So you can little,
okay, sir.
Increase your voice and talk, sir. Please.
Yes, sir. Yes, sir. My voice now audible, sir?
Yeah.
Yeah, it is audible.
Okay, yes, sir. Thank you, sir.
Okay.
So myself, P. Anbarsan, Associate Professor. I am belongs to Department of Electrical Engineering, Vellore Institute of Technology, Vellore. So now I'm going to share my slides. I'm going to deliver the topic energy conservation for present and future. So first the roadmap. What is energy? So the energy definition, energy conservation definition. Why we have to conserve energy? The types of energy. So the types of energy, the solar, wind, hydro, nuclear, etc. I listed some of the energy, how they are going to be convert electrical power. The electrical power convert to electrical energy. The energy conservation in industries. So what are the apparatus or the device they are using in industries? In what way we are going to save the electrical energy? So the methods. Energy conservation in India. So in India, how we are going to be conserved? So for that saving power, the loss, minimize the losses in such a way, the energy we are going to save in India. What actually we are going to be do? So based on this, we are going to create the awareness. The government of India, they are formed Bureau of Energy Efficiency. So it's acting from since 2001 and 2002 onwards, they are operationalized or acting Energy Act. So for that, they are creating awareness to the peoples. So how we are going to save the powers. Now, what is energy? Energy is defined the ability or capacity to do the work. That is energy or power into time. How many hours we are going to be used the work very effectively. The energy light our cities, power our vehicles, run machinery and factories. It cools or warms our homes, plays our music, and gives us picture on television. So, what is energy conservation? The energy conservation is the practice of decreasing the quantity and quality for the output. Energy, how we are going to be usage. It may be achieved through efficient in use, which case energy use or decreased while achieving a similar outcome. Energy conservation also includes prevention of misuse of energy, right? So the people they are misusing that's and all how to eliminate for that. Next, our energy demand in India. Every year, India is a developing country. So for that, every year the power is increasing. So in June 2020, the India energy demand contracted 10.9 percentage. For the consecutive month, 105.6 billion units, while energy supplied also decreased 10.9 percentage. So, according to Power Ministry or Ministry of Power Corporation, the peak power demand in the May 182.53 or 1,82,530 megawatt. The peak power demand met 1,31,400. The shortage is 51.13 gigawatt in India. So we want to the how to conserve the energy. So to make up the gap between supply and the new power supply and demand, the new power plants we got to be installed in India, or we got to require the capital and time. To meet growing demand, it has been assessed the additional generation capacity 1 lakh megawatt has to be added by 2020, requiring an investment or 8 lakh crore approximately. An alternative is energy conservation. The energy conservation measures can reduce power demand and building up additional generation capacity to extent it can be conserved. So this is why we have to be conserve energy. The other points, we have limited resources of fossil fuels available on Earth. 60% resources are consumed so far. So we have to sustainable growth or the uniform growth, save resources for future generations. Energy conservation is also one of the way to achieve this. Our electricity will becomes less. Okay. The next point, so that energy conservation not only the technological issues, it encompasses much broader economic and management issues also. The management issues are encompass how to operate, how to switch on or switch off by using the equipments in such a way also the managing. The cost effective energy conservation measures well established 1 unit of energy saved at the consumers avoids nearly 2.5 to 3 times capacity augmentation due to the planned load factor, plan availability, auxiliary power consumption. The thermal power shares about 65% of total electricity in India and also in the worldwide. The poisonous gases such as carbon dioxide, nitrogen oxide, sulfur oxides, and ozone ash are released to the atmosphere, causing environment pollution. The carbon dioxide is one of the main factors for global warming and climate change. So this and all by operating that plants, apparatus, devices. What are the types of energy? The types of energy they are using. Renewable energy. It is the energy obtained from sources that are essentially inaccessible, such as sun and wind, or the energy system converts energy found in sunlight, falling water, sea waves, wind, geothermal, or biomass into form we can use such as heat or electricity. Non-renewable energy. Non-renewable energy, it is energy that comes from ground and is not replaced in relatively short amount of time. Thermal power plant using fossil fuels such as petroleum, natural gas, coal, oil, etc. A nuclear power plant. Some of the examples I listed here. What are the energy they are using? Solar energy, wind energy, hydropower, geothermal, tidal, ocean. In addition, biomass also there. So the power that I am some of the few energy I listed here. The solar energy. The solar power is a promising and renewable energy resources then can be turned into electricity and it is used in many toys, many toys and even home heating. So here just the figure shows that solar power conversion to how we are using in the home appliance, the remaining how to connect the line. The wind energy, the wind power is increasing, used as clean source of renewable energy source. The turbine harvest or wind farms and generate electricity. The hydropower. So the hydropower plant, so from that water, whether water flow or normal flow of water, that electricity is we are going to be, that electric power or energy we are going to be paid. The next geothermal power. The geothermal power uses Earth's natural heat and generate electricity. The tidal power. The tidal power is formed hydropower that converts the energy obtained from tides into electricity. So the figure just explaining how that through hydro, the tidal power we are going to convert to electricity or the electrical energy. The next ocean thermal energy conversion. Sorry. So here how that ocean thermal energy is converting the figure. So now that slides, what is energy, the energy conservation, what is energy conservation, why we are conservation energy. So the sources of energy. Now the sector wise in India, the data are just giving the guidelines, the energy consumption, the percentage. So agricultural side 5%, industry side 49%, transportation 22%, residential side 40%, the others means etc. 14%. So this is energy sector wise. So the possibility. So this is energy consumption. So the possibility of saving. So economy as whole up to 23%. Agricultural economic side. Agricultural side we can use up to we can save up to 30%. Industrial side we can use 25%. Transportation side, domestic side. So these all sectors for agricultural in village, many of them they are just switching on. So within that time they are not switching off. Industrial side, so like induction motors or like whatever that device instrument we are going to be use switch on or switch off, the operational time, right? Or voltage fluctuation or the operational time on the how we are going to be operate. So based on that we can able to the possibility we can save for this. The electricity used for lighting. So nearly 10% of electricity is consumed for lighting in the commercial building and domestic side. So this amounts to approximately nearly 11,000 megawatt. The annual electricity consumption charge nearly 50 billion kilowatt hour. So this we can able to save due to the lighting side. Saving in lighting side. So how we are going to be save that operational side. So make maximum use of natural light. Switch off when not required. Modify lighting layout to meet the need or demand by the time. Select light colors for interiors. Provide time switches or PV controls photo sensors. Lighting transformer to operate to reduced voltage or install energy efficient lamps, luminaries and controls. Clean translation seat and luminaries diagram. So these are the way we are going to be save. So based on that we can able to save the energy. So money we can save. So here there's some chart I given the details. The energy efficiency and energy cost, light emitting diode, incandescent light bulbs, compact fluorescence. So the incandescent light bulbs traditionally we are using for this. The compact fluorescence side recently we are going to be used. So for that the energy consumption hours, the power energy, the power savings, the energy that's under reduced. So the totally the cost will be saved. So that's why the compact CFL labs nowadays very famous for this. In many areas, many places now they are replacing for this incandescent lab that compact CFL labs and all they are using for this. So the lifespan, watts of electricity used, units of electricity, and light emitting diode, incandescent lamp. So the annual operation cost will be less. The next energy saving in lighting side, the separate light transformer, isolate from power fader to avoid voltage fluctuation problems, energy saving at optimum voltage. So normally the plus or minus 5% variations in voltage side and frequency side, normally the electricity board we are going to be about. Voltage if it is high voltage, okay, high voltage it goes means high voltage the bulb duration will be reduced. Low voltage, more magnetizing current, more loss. So these are the reasons the voltage fluctuation we have to be maintained by using voltage stabilizers or stabilize equipments. So the voltage by maintaining plus or minus 5% frequency plus or minus 5%, we can maintain the level. So the apparatus also, even apparatus electrical side, all generators, motors, everything they are designing plus or minus 5%. So for that, the minimum side and maximum side we can able to maintain for the losses side and the duration side, the life duration or the durability. In installed servo stabilizer, the same stabilizer also we are going to use for the voltage, stabilizing the voltage plus or minus 5%. So this we are going to save from the lighting side. That fan side, fans are extensively in summer months. So use of high efficiency motor, use of electronic regulator in place of conventional resistance regulator can be 20% we can say. So the electrical side, electrical side everything 10 power plus ampere, kilo ampere, mega ampere, giga ampere. Electronic side everything 10 power minus, milliampere, micro ampere, nano amperes. So electronic switch, it will be, if you are going to be used the regulator side or fan side, so minimum milliampere level, microampere level. So for the I or voltage drop, I squared or the power loss will be very less. So we can able to save 20% of energy in the fan side. The next, the refrigerator side. The refrigerator side, just the ratings. Say for example, in Indian side, the refrigerator side efficiency is very poor. The 165 liter in Indian refrigerator consumes nearly 540 kilowatt hour per year. In other hand, that Korean side model comes 240 kilowatt per year. So high efficiency refrigerators we get to be manufactured in India. So this designs the refrigerators we have to be improve and we have to manufacture them. So use unless quality of electric supply is improved, this refrigerator cannot be improved in India for effectively or saving energy. Energy conservation in industries. So some of them, the motor, even boilers, right, etc. Also there. Some of the device I added here. Energy saving, differential industrial equipments. The motor side, air compressor side, pumps, cooling towers, the lighting side. How we are going to be operated. So saving in motor side. So most of the induction motors in industry they are going to use or nearly 90% or 90 to 95% induction motor only they are using. So induction motor consumes nearly 70% of total electrical energy generated. So the capacity of the motor proportional to torque and proportional to V square. So the energy we are going to be reduce or how we are going to be the various causes of energy loss in induction motors are due to the following factors: oversized motors, rewound motors, improper voltage, less efficient motor driven equipment, idle run. So these are the reasons the energy loss in induction motor side. So sizing of motors play a vital role in energy efficiency. It's very difficult to choose right size of motors in single step in applications. So step by step or 2-3 stage we got to be involved for choosing the proper size for saving of energy. The major reasons for oversizing motors may be the starting torque requirements, excess caution and safety factors, ad hoc decisions. So these are the reasons. And rewound motors. The rewound motors common in Indian industries, especially in textiles, unorganized sectors, paper industries such as floor mills, lathe shops, and agriculture farms. Induction motors used after more than 4 times rewound. Reasons for loss in efficiency rewound motors. The eddy current loss in proportional to the square of the thickness of the laminations. So the normally the solid shape we may not going to be used. The thickness or lamination only we are going to use 0.35 millimeter to 0.5 millimeter. So for that, the frequency of flux reversals, the current flow in the conductor side will be reduced. So loss are going to be reduced or energy can save. The improper voltage. So the improper voltage induction motor, it's in synchronous motor is possible for we are going to maintain the voltage, but induction motor the supply voltage itself 415 voltage generally will be less than 415 voltage in the motor side we are going to be operate. So this will be case in many of the imported motors designed for the frequency and voltage in Indian frequency and voltage. So the improper voltage. The next, less efficient motor. So earlier variable speed welding applications, the motor generated sets are used. This is the energy inefficient practice. So This offers a good scope to reduce energy consumption by using the latest technology to meet the requirements. So yeah, earlier they used motor generated sets. Now the latest technology, by using this, we can able to save for this. For example, the recent method to get accurate variable speed control can be achieved by thyristor control or thyristor drives, which is the ideal replacement for ward linear drives. The olden days, the ward 2 generator and one motor, the speed control method that is going to be used. So the latest technology, by using thyristor, we can able to reduce the loss or save the energy. The next, idle run. In some of the industrial applications, the auxiliary equipment need to drive or run even the main equipment is switched off. There is possibility to switch off whenever possible by incorporating controls like interlocks, timer-based controllers. This will reduce the idle running time and energy consumption. In energy side, air compressor side. So the air compressor side is very energy intensive. Only 5% of electrical energy is converted to useful energy. Use of compressed air for cleaning or rarely justified. The cooling towers. The cooling towers, specialized heat exchange, which two fluids or air and water brought into direct contact with each other, effect of transfer of heat. So install automatic on-off switching cooling towers, fans, and save up to 40% electricity cost. So similarly for pumps, the pumps also, we are going to save, select a pump or capacity in accordance with requirement. Improper selection of pumps can lead to wastage of energy. Pump 85% efficiency rated flow may have only 65% of efficiency to half the flow. Matching motor size with appropriate size. So these are the points how to save the energy. Similarly, the lighting side. Clean the lamp and fixtures regularly. Illumination levels falls by 20 to 30% due to collection of dust. Use of 36-watt tube light instead of 40-watt tube light save electricity up to 8 to 10%. The sodium vapor lamps for area lighting place of mercury, so we can save electricity up to 40%. Okay, so what are the ways, the apparatus by choosing or operating, so we can able to save the energy, the percentage. The next, energy audit. So the Bureau of Energy Efficiency in India, they are formed in 2001 and 2002. So for that, the Energy Bureau of Energy Efficiency, their auditors are there coming. So the energy auditors inspecting, analyzing, and evaluate the energy consumption. They assessing how much energy the industry uses, pinpoints opportunity for saving energy. Accurate measurement of energy consumes necessary for energy audit to arrive energy conservation measures. Next, the reduction of line losses, replacing smaller number of larger transformer with large number of smaller transformers located near the load, reducing the length of low tension lines. Such an arrangement will result better voltages, increased transformer life, easier replacement, less outages of failed transformer, and few consumers are affected by transformer failure. The improvement of power factor 0.9 through LV switched capacitor panels on all transformers supplying to pump sets. The energy conservation in distribution side. The use of energy efficient transformer, amorphous core transformer to reduce no load losses. Actually, that amorphous core transformer recently they are used commercially, but not like they are using like silicon seed strip. 0.35 millimeter, actually 0.27 millimeter thickness of the plate they are using in core type of transformer. 27 micrometer they are using in amorphous core transformer. So the amorphous core transformer we are going to be used the KVA, the line loss silicon steel. So for that, the loss will be less. In every day, we can use work at conserve energy. Or what actually we are going to do. So what is energy? What is energy conservation? Why we are conservation of, we go for this. So what are the source of energy in industries by using the lighting system, the motor system, air compressors, by operating, etc. So we are going to save the energy. So how we are going to be daily our life, we are going to conserve the energy. So insulating turn off lights and using appliances like dishwashers when they are full or just some of the ways people can limit energy use in their homes. Turn off electronic devices that are not in use. Not only turn them off, but try to remember unplug them. So we'll surprise how much the energy will be saved in one step or simple step. Also carpooling, bicycling, taking public transportation or effective energy saving ideas. The energy conservation in India. The Energy Conservation in India Energy Act per unit gross domestic product is much higher in India, 3.7 times Japan, 1.5 times of USA. Then many of our countries are the world leading high wastage of energy, the power shortage, and uncompetitive product pricing hindering international trading. Potential of 25,000 megawatt energy saving. Energy conservation can reduce peak and average demand. We know the peak demand and average demand. One unit avoids 2.5 to 3 times plus capacity addition. Investment in energy conservation is highly cost effective. Can be achieved less 1 crore per megawatt. The energy conservation, the data in 2015 and 16, actually the 2019-20, the net or it's not available. So 2015-16, I am highlighted here that megawatt power saved 9355, energy saved 19190 mega unit, money saved Rs 191,000 million. So reduction of carbon dioxide, the pollution 40 million ton. So the Energy Conservation Act, so they are established in 2001 and 2. So the TAP and Huge Energy Conservation or Potential Energy Conservation Act was enacted in October 2001, effective from 1st March 2002. Energy efficiency operationalized from March 2002. So the standards and labeling. So that Bureau of Energy Efficiency giving manufacturers and the consumers how the standards and labeling we are going to be save the energy. So the standards and labeling evolve minimum energy consumption and performance standards for notified equipments and appliances. Prohibit manufacture and sell equipment appliances not conforming to standards. Introduce mandatory labeling to enable consumers to make informed choice. And standards. The energy efficiency maintain the standard or procedures and regulations that prescribe the energy performance manufactured products, sometimes prohibiting the sale of products less energy efficient than the minimum standard. So the standard, if it is minimum, less than minimum, so it will be prohibit the manufacturers. Labels. Energy efficiency labels or informative labels affixed to manufactured products indicating the product's energy performance in order to provide the data necessary for making informed purchases. So the consumers, they can understand the proper labels are affixed so they can buy if it is minimum standard. The Bureau of Energy Efficiency, that important role. So implementation of provision of Energy Conservation Act, coordination, policy research, promotion of energy efficiency, development of new financial instruments, the awareness creations. So this we can do. So the Energy Conservation Day, December 14th, just we get to remember and we get to create the awareness to our peoples, how we are going to save the energy. So for that we can save the money and we can operate the electrical instruments apparatus effectively for that. So this is I presented very short period. Thank you. If any questions, I will try to answer for this.
Thank you, Mr. Amberson.
Yes, sir.
So I want to know what is the present level of transmission loss in terms of percentage.
Yes, sir. The present transmission loss in India, 24.2%. 10 years back, nearly 33% approximately.
Okay.
33% in Indian transmission side and distribution losses.
It is one third.
Now in present, last year when in my research work I referred 24.2 to 25% transmission loss in India.
1/4 it is one.
Yes, sir.
Okay.
Sir, am I right,
Good.
sir?
Yeah, you are correct.
Yes, sir.
I want to know what is the theft level in the India, energy theft, in terms of percentage.
Yeah, this is including, sir, including 24.2%, including the theft, sir. Total, this is what? Nearly, I'm hopes of probably 8 to 10%, sir.
Okay. So you have clearly mentioned what are the preventive measures
Yes,
to
sir.
conserve energy,
Yes, sir.
in domestic appliances.
Yes,
One
sir.
more thing I want to tell you, in the industry part,
Yes, sir.
already large scale industries and heavy industries
Yes, sir.
are poised to save energy conservation.
Yes.
Okay, that is one of the major part of energy consumption is in engineering industries, welding equipments.
Yes, sir.
So already they have gone for introducing the welding inverters.
Yes, sir.
So it drastically reduces the consumption of power.
Yes, sir.
Okay. Another one is cranes and electrical appliances.
Yes, sir.
Okay. Cranes, motors, and everything is converted into variable frequency drives. Okay.
Yes, sir. Yes, sir.
So one more thing, another thing about is that in fabrication industries,
Yes, sir.
lot of shearing machines, power presses,
Yes, sir.
press brakes and presses, they switched over to present conventional type to hydraulic operating systems.
Yes,
That
sir.
drastically reduce the consumption of the power. Okay.
Yes, sir. Yes, sir.
So another part it is compressors.
Yes,
So
sir.
they also switched to present reciprocating pump to compressors, screw
Yes, sir.
compressors.
Yes, sir.
Though the screw compressors are drawing power 3 times during the starting up. So after once it is established, if power is getting reduced, they have also switched over to screw compressors.
Yes, sir.
Okay.
Okay,
Okay.
sir.
These are in industrial part. I want to share these things to you.
Yes,
That's
sir.
all.
Yes, sir.
Okay. Thank
Okay,
you
sir.
for your well preparation and well presentation.
It's a very
Okay.
short period, sir.
No
Very
problem.
short
No
period.
problem.
Sir.
Okay.
Okay, sir.
Thank you. Thank you, Saleh.
Thank you, sir. Thank you very much.
இவர் எஸ்எஸ் மணி சார் கூட ஜாயின் பண்ணிருக்காரு போல சைலண்டா இருக்காரு.
ஆமா.
Okay.
Now they can unmute and talk.
Okay.
Whoever wants to talk, they can unmute and talk.
Okay.
Sir, I am son.
Yes, sir.
Hello.
Yes, sir. Yes, sir.
Sir, I am Anbarasan. I have one question, sir.
Yes, sir.
Sir, you told that for refrigerator there is a Korean refrigerator which can save 50% energy when compared to normal refrigerator.
240 kilo.
What is the technology behind it, sir?
Technology. Sorry, sir.
Okay.
Sir, can I answer for that question?
Yes.
Actually, the nowadays original design was to continuously running the compressor throughout the period of cooling, and it will be switched off when the temperature reaches to the desired level. Now they have changed it to like a variable frequency drive like thing in compressor also. The required amount of refrigerant only will flow through the compressor. So always there will be to the need only the machine will work. And there is an inverter technology introduced into the refrigerators also nowadays. So it also gives us a better energy saving in the energy saving context, and the amount of energy spent we are able to practically see that 5-star 4-star rating refrigerators is comparatively more than 50% energy savings is really achieved in our household application. We have practiced and tested also.
Okay. In Saleh, one more thing.
Yes, sir. Yes, sir.
In VFD is possible in AC also?
Yeah, it is there. No, it is called like inverter power, and the compressors with variable refrigerant flow through the compressor based on the temperature requirement.
Okay.
Like that. Yeah, it is coming in AC also, sir. Inverter,
It is coming.
that you have to ask for, and the star rating also you should go for higher star rating. So it will be a little costlier, but it is like you will be offsetting the savings in a very short period, sir. Maybe in 1 or 2 years itself, a 5-star rated fridge or AC will give you the extra amount that you are going to invest in your purchasing of this AC or fridge. And similarly, LED part of lights, that is also going to be very useful in power saving aspect. And yes, sorry, sir.
Salai?
Yes, sir.
Thank you for your reply. And I like to know whether these Korean refrigerators are available at present in India.
Dr. Anbu to answer.
Sir, I will send guide, sir.
We'll explore for it.
Yes,
okay, sir.
Actually, this LG certain brands are from the technology from the Korean, I think. LG and all is from the Korean technology one. We'll explore it.
Okay, we will refer to Google.
Yeah, definitely.
Thank you.
Thank you, thank you.
Okay, thank you, Salai. Number VIT ஏதாவது போய் சாரை பார்த்துட்டு கொஞ்சம் இண்டஸ்ட்ரியல் விசிட் கொஞ்சம் அரேஞ்ச் பண்ணலாமா அங்க?
Yes, sir, most welcome, sir.
Okay,
sir, I will
okay.
contact you, sir.
Yeah,
And,
Dr. Anbarasan, I am resigning at Katpadi only.
Yes, sir. Sir, I am staying in VIT quarters, sir.
Okay, I want to share something regarding that this energy conservation.
Yes, sir.
So whenever you are free, I can contact you. And okay.
Yes, sir. நீங்க என்னோட phone number சார்ட்ட இருக்கு சார், சாலிமனன் சார்ட்ட.
நான்
Just நீங்க கால் பண்ணிட்டு
வாங்கிக்கிறேன்.
வாங்க சார்.
Okay.
Yes,
Okay.
Then, sir, one more announcement that in the ensuing week, next week, middle of the week, we would like to have one industrial visit for the solar plant available in BHEL. We have got a 5 megawatt solar plant, and it is catering to the need of the BAP's electrical load demand, and this will be an interesting feature to see by engineers. In this, I would like to request all the people to get in touch with us for the date exactly, and so that we can make the industrial visit also fruitful.
So what is the date actually? You told me some date and all.
No, next week middle. I wanted your exactly the consent
18 to 20, the 18, 19, 20, the 3 days.
Congress is there. We will not have that then.
Sir, I am having one question, sir. Sir,
Yes.
Manala. Sir,
Yes, sir.
our VIT students, is it possible? Can we visit that solar plant, sir?
It's through this IEI banner we can visit.
Yeah, you can. How many students will join? Salai.
We will have it.
Salai, you can ask him how many students can visit.
That's
from
what
VIT.
you can. If the people who are really interested can join, 3 or 5 people, you can join with us on the day when we make the visit.
Okay, sir. That means the project students who are in the group who are working in that area.
Definitely.
Yeah.
Okay, sir.
Okay.
And because of this